So we're going to finish up that online worksheet that we made together, or that I made and we started together last week. And then we're going to get into rotations. I'm going to shoot for 10:30, okay? Or 11:30. What time is it? 11:30 a.m. I'm going to shoot for starting our new stuff at 11:30. So we've got about 25 minutes left. So most of you did start your worksheet already. Um, go ahead and please do this for me. Go to your Gmail, or you can go to Google Drive. Might be a better idea to go to Google Drive right now. And at the top of your Google Drive, chances are you're going to have your reflections in the coordinate plane activity ready to go from last week. So if you've already started it, your work will be there. I checked this morning. And if you haven't started it yet, that's okay. Instead of doing small groups, I think we'll do it as one big group today. But I want you guys to have your own open and working on it together as we all do it. Okay. And instead of, I really don't want to like call people out and say, you tell me the answer to this and you tell me the answer to that. So I'm going to just do open questions and I'd like to see you guys trying. And if we don't get the same exact answer, is that a big deal? No, we just need to try. And in talking about it together, we'll learn better how to do these things and then learn about the rules of reflections too. So please go to your Google Drive and pull up your reflections on the coordinate plane. I'm not going to do breakout rooms. I'm going to cancel that. We're just going to do it as one big group. But I do want to see you guys each have your own open. Welcome, Xavier. I'm glad you made it. You haven't missed anything. All I'm asking folks to do is that we're going to pull up those worksheets we started last week. We're not going to do it in small groups. We'll do it in one big group. But I am going to have you guys participating with me. So please work along with me. And I'm going to ask you to help me answer the questions and we'll do the slides together. So I'm going to switch over. I'm actually going to stop sharing right now and pull up your guys' different activities so I can see and help you get logged in. So I think Tatiana just got in hers and Anaya, high five you too. And if you need help finding it, just tell me. I'm here to help.
Good morning, teacher.
Victor, good morning to you.
Good morning.
Okay, Victor, what we're doing is we're finishing the activity that we started last Thursday. So please go to your Google Drive and then along the top, you guys will see reflections in the coordinate plane and then your name. Like you each have your own copy. If you have started it, some of you did start it last week. You were going to just pick up where you left off. If you haven't started it yet, it's not the end of the world. You can still do it today. Instead of doing it in groups, though, we're going to do it together in the class, all together in one big group. Okay?
No.
Awesome. So I'm monitoring to see you guys get logged in. I see Levi just got into his. Savannah. Oh, no, Levi did not get in. Let me refresh. My bad. There we go. That's from last week. Okay, Savannah's not even here. So Tatiana and Anaya are in. Thank you, you two. So let's see who else is here. Levi, Xavier, Victor, and Brooke and Anthony. I want you to go to Google Drive and then open up your reflection on the coordinate plane. Remember, we're not doing it in small groups. We're going to do it in one big group. But I want to have you guys help me. We're going to work through it together. We got 20 minutes. I think we can do this as long as we're all, trying. We can totally get it done in 20 minutes. And then we're going to switch over to rotations. Okay?
I think I'm on it.
Anthony, high five to you. Boom. Sorry if I'm missing other folks. Yeah, it doesn't. Let me see, Anthony.
Can you check on me, teacher, if I am in?
Anthony, are you in the one that's... Oh, you are in it. There we go. Thank you. Thanks, Anthony. Yeah, and Victor, I'm going to check yours too. I'll pull up everybody's. I guess my Google Drive is not as fast as you guys are logging in. Okay, Brooke, I see you logged in. Go ahead and everybody, Anthony, Brooke, Victor, Xavier, all of you, please start by at least putting your name at the front on the first page. We're going to skip names of your partners. So I'll tell you what, if you haven't put in a name for your partners like from last week, just say the whole group. Can you do that into names of your partners? Type in whole group and do your name. Okay, Victor, I'm loading yours now.
I can't put my name in it.
What?
Let me.
It's not letting you type? Brooke just got hers in. Let me double check yours, Anthony. I see you clicked on it and it won't let you type. There we go. Yay, it's working. Good job, Anthony. And Brooke, I see yours. And Victor, I don't see you in. So I'll tell you what, bud. I'm going to just really quick send you the link to this thing. That help? If I text you the link to yours? Levi, I see that message. Thank you for telling me. Thank you. I appreciate that. My bad, but I appreciate you telling me. Victor, I'm going to chat you your link to your worksheet.
Yeah, teacher, please, because I don't find it.
Okay, I'm going to chat it directly to you in this Zoom call. Victor, there we go.
Okay.
There we go. This should work. Okay, go ahead and click that link, bud, and then you should have yours open, and it's just yours. Only I can see it, but we're all going to do it together. So once I make sure you're all in and you all have your names in there, we'll go through the slides together. Okay.
Okay.
All right. And how about you, Xavier? Did you get yours open yet?
Yes.
High five, dude. And I see you've got your name in there. Perfect. Okay, the next step for everybody, while you're getting in, you're typing in your name. On the first page, the first slide, I should say, see that link at the bottom, reflections in the coordinate plane activity? I need everyone to click on that on your own. Click on the link. You'll get a little pop-up, and you click on the pop-up. I'm going to go ahead and share my screen again so you guys can see me do that in case you need to see it. Okay, so come back to the Zoom call, and I'm going to open up my version of this thing. Okay, so here's mine. On the Zoom call, I'm showing you. On the first slide, there's that weird blue link at the bottom, reflections in the coordinate plane. Click on that, and then you have to click on the little pop-up. It'll open a new window. And this page is going to load. We're going to be using this. So you need to have this thing open and then your slide. And you're going to flip back and forth to type in your answers on the slide. Savannah, I'm glad you're here. It's okay. Savannah, what we're finishing up is that Google slide from last week. So please go to Google Drive, open up your reflections in the coordinate plane slide from me, and then open up this thing again, Savannah. It's the actual GeoGebra. The link for it is on the first page. We're not going to do them in groups, Savannah. We're just going to do it in one big group. Okay. And I want to try to have it done in about 17 minutes. So I'm sorry I'm probably not going fast enough for some of you. So thanks for your patience for folks who are ready to go. I'm going to stop sharing again here. Okay, Savannah, I know you can find yours. So go ahead and get logged in, and Xavier's in his, legit. So here's what I'd like you guys to do while you're waiting for me to start it together. You should have your GeoGebra open. That's the reflections in the coordinate plane activity from the first slide. So you've got your GeoGebra open. Look at the first figure, the ABCD polygon. And what I want you to do is on slide number 2, back on your Google slide, you're going to type in the coordinates for A, B, C, and D. Not even using like reflection 1 or 2 or 3 or 4, just A, B, C, D. You don't have to watch me on the Zoom call. I am going to share my screen now. but I'm not going to answer the questions. I want you to answer them and help me. So I'll tell you what. Is anyone willing to help me now with the coordinates for A, B, C, D, the first polygon? So if you, let me pull mine up here. Here we go. So we did, most of us did do this last week. So I know some of you already have these typed in. Would anybody be willing to share? Sorry, Levi, I think I cut you off.
It's all right. So I'm doing the reflection 1 points, right?
Okay, let me just stop you. Can you, before we do reflection 1, what's the original polygon, A, B, C, D, its points?
Those points are 4 on, so let's see.
Let's do A, just point A.
I think A is going to be 4, 1.
Okay, right numbers, but it's always the X first and then the Y.
1, 4.
Good. So everybody, for our first slide, we're typing in point A and it's 1, 4. Thanks, Levi. Oh, and I didn't take my old ones out. So A is 1, 4. Good job. And then we want to type in B, C, and D. And the point of this exercise that we're doing is once we do our reflection, we're going to take down those points as well. And then we're going to compare the X's and the Y's. See if there's a pattern or like a process that we can use. Okay, in the chat. Tatiana, high five, dude. Okay, guys, so Levi's on the knows what's going on and Tatiana knows what's going on. Can someone else, I'm going to ask for it to be a third new person. Would a third person, that's no offense, Levi, Tatiana, you can answer again in a second, but for this one, can someone tell me point B? The original ABCD, what's point B's location?
For B.
Yeah, B is in brittle. B is in boy.
1, 3.
Very good. Is that what was Anaya?
Yeah.
Okay, thanks, Anaya. 1, 3. Awesome. All right. Now we want to do C and D. So back on our GeoGebra, point C, that's over 3 and up 3. You see that? You look down at the X line, that's its X coordinate, and then look over to the Y line, that's its Y coordinate. So for C, we're looking at 3, 3. Can I get a volunteer to help me with point D? Anybody? What did you get for point D? D as in dog.
I got 2, 4.
Wonderful. 2, 4. Legit. Was that Savannah?
Yeah.
Thanks, Savannah. All right, guys. Now, if you haven't done it already, and I know some of you did get to reflection 1, we're going to click on reflection 1 and back on GeoGebra. Mine's a little funky. You might have to kind of scroll up or down to see these things. I'm going to click on 1, and then now you should see another polygon pop up on the left side. And these are marked as A prime, B prime, D prime, C prime. So it's a new figure in a new place, right? And it's positioned in a slightly different way. So now let's copy down those points. So the A prime point, the reflected A, that one is at -1, 4. So if you look down from A prime, you see how it's right above the -1. So its X coordinate is -1, 4. So for A prime, let's type that back into our slide, -1, 4. I'm going to do point B, and I'm going to ask for volunteers on C and D. Point B is at -1, up 3. So back on our slide, we can type that in. B prime is -1, 3. Okay. Can anyone help me with C prime, the reflection for C? I see some chats. Oh, Savannah and Anaya, thank you both. -3 up 3. So folks, and Tatiana, nice job. So they're getting -3, 3 for C prime. It's if you look down from C prime, it's at -3, and look over and it's at +3. X then Y. So let's type that in. Cool. And then do the same for D. D is in dog. -2 up 4. Okay, everybody, or anybody who's willing to share, what is the line of reflection for reflection 1? Meaning, what is the axis or the line equation that's separating right down the middle these two pictures, these two images? Anaya says the y-axis. Thank you, Anaya. Wonderful. The line between A, B, C, D, and then the new version is the y-axis. Good, Savannah and Tatiana. Good job, guys. So let's type that in. The line of reflection for reflection 1 is the y-axis. Okay, so for part 4 or question 4, what I want to do is basically describe what we're seeing between the points, the changes in the points. So everybody, look up above at part 2 where we typed in all the points. Let's compare A to A prime, B to B prime, C to C prime. What do you see that's changing and what's staying the same?
The x-axis is changing from positive to negative, while the y-axis is staying positive.
Yeah, exactly. Good. Well said. The x numbers are changing from positive to negative. The y's are staying the way they came. So let's type that in for our response. It doesn't have to be exactly what I'm describing it, but you can word it differently, is what I mean. The x numbers or values are turning negative, becoming negative. The y's, y numbers are staying the same. This happens anytime we reflect over the y-axis. The y values stay the same. The x's all become negative or negated, really. So we're going to move on to reflection 2 now. But before we do, look back at your GeoGebra or look at my screen. What if we had started over here on the left side and then we reflected over the y-axis? Then it would switch from negative x's. They would become positive x's. So when we reflect over the y-axis, whatever the height, the y numbers, those always stay. But the x numbers switch from negative to positive or vice versa. And that's the that's our like rule, so to speak, our pattern that we can use for reflecting over the y-axis. Okay, let's look at number 2, reflection 2. So this is the next page, slide 3. Now I put in there on every reflection page that we have to type in the A, B, C, and D, the originals. So I want you to do that again. I want you to type in A, B, C, and D, and these are the same as what we got before. So 1,4, 1,3, and so on. So let's type those in on reflection 2. And we're going to look at clicking reflection 2. So if you're ahead of me, go ahead and do that. Click on your reflection 2, and you can unclick on reflection 1 so it's cleaner and we don't have to look at reflection 1 anymore. I'm going to stop sharing at this point and check on your guys' work. I still want to walk through it as a group. Once you've got all the A, B, C, D points typed in, we're going to type in the points for reflection 2. So we need to practice this together. So I'm going to unclick on reflection 1 and do number 2. Now on my screen, guys, I didn't see reflection 2 right away. I have to actually scroll down in order to find it. you might have to back out of uh, the image of your graph. I have to like zoom out kind of, and I had to scroll down. Okay, now floor is open. Can anyone tell me, looking at reflection 2, what is the A prime XY? What is the location of A reflection 2?
1, -4.
High five. Very good. It's the A is at 1, -4. Type that into your sheets. And does anyone have B ready to go? B prime.
1, -3.
Good. Very good. And now we have to do C and D. Notice that the shape is the same, right? It's the same polygon. It's just been flipped. But like the proportions are all the same. It's like the same exact shape. All we've done is kind of folded over that line. Okay, so for C, can anyone tell me the location for C's reflection?
3, -3.
Good. And then for D reflected, we get 2, -4. All right, let me check out some of your guys' work here. Victor, good job. I see you got those going. You're almost done with that one. Keep going, bud. Xavier, you coming back? All right, Xavier, I'm glad you made it back. Xavier, are you having trouble getting into the GeoGebra activity thing? Do you have any questions on that?
No, I think I'm good. Wait, let me see. Hold on.
Okay. I'm just worried because it looks like I thought you just like dropped out of the call, but you don't have any of your points typed in for reflection 1?
Oh, okay. Sorry about that.
Is it letting you type in those yellow boxes or no?
No.
No, really? Darn it. What is going on?
Teacher, is the same reflection 1 and reflection 2?
No, Victor, they're different reflections. Good question.
Because they're asking the same, I think so.
Yeah, the questions I put on each screen are the same, but the reflection line changes in each page. So, Victor, notice how when you do reflection 2, if you click on reflection 2, it's a different image that pops up. There's a new like reflected polygon of ABCD. It's in a different place. Do you see that?
Yeah, I think so.
Maybe maybe it's not zoomed out enough. Would you mind, Victor, really quick sharing your screen and I can see what you're seeing?
Yeah, I think it's the same question, teacher. Yeah, hold on one second.
Yeah, correct. The questions I put on there are the same, but the line changes for each reflection. So that'll
Well-
change the points.
One second.
Okay, thank you. Awesome. Thanks, Victor.
Okay, so this one is the same questions right here.
Correct. I understand. The questions are the same, but your answers will be different because the lines are changing. The line of reflection is changing, and then like what happens between the original points and the reflected points is changing. So do me a favor, Victor. Click on your tab to take us to your GeoGebra activity. Okay, I see. Go to page 1 on your Google slide. The top. Click on that thing. Thank you. And now click on the blue link, Victor. See the blue link at the bottom? Click on that.
This one again?
No. The bottom. It says link.
Oh, yeah, right here.
Yes, sir. And Xavier, this is what I want you to click on as well. It's on my screen right now. Victor's demonstrating. So you click on that and then click on the link, Victor. Good. It's going to
Okay.
open up your activity to actually see these reflections. So this is where the points are coming from, Victor, for A, B, C, and D. Do you see that
Okay.
orange figure right there?
Mm-hmm.
Or like pink or brown? I'm not sure what color that is. Now click
Yeah.
on reflection 1 real quick. See on the left side, there's those boxes. Reflection 1. Yeah, click on that. And there's reflection 1. So now we can see where that figure goes after we reflect over that line.
And how I move to like for reflection.
How do we do what?
Oh, yeah, right here.
There we go. Zoom in a little bit. It's kind of hard to see the points at this stage.
Yeah, it's working.
Okay. Let's zoom it in because it's too hard to see. And we'll save the challenges for later. I just want to make sure we get through reflections 1, 2, 3, and 4 today.
1 second.
So now
So, but-
click on reflection 2 for me. See how the reflection 2 is below? It's a different area where it goes to.
mhm.
Yeah. So now we want to fill in all those points, the originals above and the new one below.
Oh, okay.
If you zoom it in, you'll be able to see the actual coordinates. It's a little too zoomed out right now, I think.
Okay.
So before I let you go and have you stop sharing, try zooming in so we can read those coordinates.
Zoom it in. 1 second.
You did it a second ago. On mine, I'm using a mouse. So on your guys's, I think there is. I thought there was like a zoom in and out button on the side. I guess not. Okay, let me see.
1 second. No. So in this question, teacher, it's just like
Oh, I think I found a shortcut for you guys. To zoom in and out, Victor, you can hold Control and plus at the top of the screen, Control plus or Control minus to zoom in and out. Does that work? On the
Yeah.
GeoGebra activity.
oh, no, no.
Try doing Control plus or Control minus. Does that zoom it in and out for you?
Control plus.
You have to hold Control and then you push the plus button or you push the minus button to zoom out. See, you did it. Zoom it in. So Control plus.
Close one.
Yeah, keep going because those figures are too small. We can't even see what the points are. Good, good. Now I'll have to click on your screen and drag down so we can see your figures.
Okay, so hold on.
Yeah, if you click anywhere on the screen and like drag it down or up, you can move. There we go.
Okay.
Well, hang on. That's scrolling down. Yeah. So put your mouse in, like by the little figure. Put it by the ABCD figure, and then you want to click down and drag upwards, and that should kind of move the screen so we can see
Hold on 1 second.
center it, kind of. If you don't have a mouse, then I think we have to use the touchpad. You're going to click on the screen where like the graph, and then
So it is like
and then move your touchpad so that way you're like yeah, there you go. That's better. Now you got to zoom it in because it's too zoomed out still.
Yeah, because it is really to move, like, it's not like onto.
Okay, you know what? It's 11:35. I just realized something. Here's an idea. Here's what I want to do for the rest of today. I'm going to stop you sharing, Victor. Thank you, sir, for doing that. I appreciate it. So, Victor and any of you who are also are having trouble like operating GeoGebra. If anyone is having trouble operating GeoGebra, I want you to do this. I want you to go to my Zoom call again. I'm going to share my screen again. And I'm going to do it on my screen. If you can't operate your GeoGebra, if it's hard to like zoom it in and center it like this so you can actually see those points, then do it with me, but you can still fill in your answers back on your worksheet. So here's mine. So the first figure is always the same, A, B, C, D. So I've got those typed in. So for reflection 2, please type in the right numbers for A, B, C, and D again. It's 1, 4, 1, 3, and then C and D are 3, 3, and 2, 4. Those are the locations of the first polygon. And now we got to find the locations of the new version. So I go to my GeoGebra. I'm looking at the new reflection. It's at 1, -4, and then 2, -4 for D. I think Savannah and Anaya were telling me these ones earlier. So let's type in reflection 2's points. So A is over 1, down 4. -4. B is over 1, down 3. -3. Now C prime, D prime. C is at 3, -3. Okay, and then D prime is at 2, -4. Okay, folks. Some of you have this from last week. Some of you might be seeing it now for the first time. What is the line of reflection for number 2, the one we're doing now? I have it on my screen. Anyone want to share that? What is the line of reflection in between these two? Thank you. Anaya? The x-axis. Very good. So for this one, it's the x-axis we're looking at. And Tatiana. Good job, you two. So now do the comparison again. We look at our first points and our reflected points. And this time we see what stayed the same was the x numbers. See, 1, 4 turned into 1, -4. So the x didn't change. And y's all became negative. Y values, y numbers. I'm going to move on to number 3, reflection 3. So any questions or comments right now before we start reflection 3? Please. No? Takers? Okay, let's look at number 3. So back on your GeoGebras, if you're doing your own GeoGebra, let's unclick on number 2 and click on reflection 3. And it looks like we do have to kind of orient and scroll down and zoom out a little bit. Now this is tricky. This is one of the 2 lines I showed you guys last week. This is not one of the axes, right? It's not the y-axis or the x-axis. Does anyone remember or want to take a guess at what this red line is that reflection 3 is using? It's okay. This one is from last Thursday. It's y = -x. It's basically a slope of -1 going right through the origin. So its y-intercept is at 0, and it's going down 1 over 1, down 1 over 1. So the line of reflection this time is y equals negative x. I did skip ahead, didn't I? What is the line of reflection? Y equals negative x. Now let's type in those points and we'll compare to see what's happening. So again, the first set is the same as all the other first sets. So A, B, C, and D aren't changing. Now we're getting into some new stuff, though. I think maybe some folks got to hear or were just getting to hear last week for reflection 3. What are we seeing for the reflected points, the A prime, B prime, C prime, D prime? Does anyone want to take a stab at answering what the how they're changing, how they're staying the same? Is anyone ready for that?
I put that the x changed to negatives and then the y stayed positive.
Are the y's staying positive on reflection 3? Maybe I got ahead of myself. Thank you for answering, Anaya. Let's put our points in for A prime, B prime, C prime, D prime. So I know this is kind of zoomed out. Let's zoom this puppy in. Okay, so on my screen, someone's got a chat here. Savannah noted in the chat that both y and x are turning negative this time. Let's double check that. Savannah, I think you're correct. So for A prime, it's -4 and its y is -1. Let's put that in our box so we don't forget. -4, -1. B prime is at -3, -1. C prime, -3, -3. Okay.
Josiah,
Levi.
I think it's backwards because isn't it the? Oh wait, never mind. Okay, so it's x and y.
Good, Levi. I see what you're seeing. You at first were thinking, oh, are we mixing up the x's and y's when we're writing these, right?
Yeah.
Are we mixing them up, or did they in fact switch places when we go over this line?
They switched places.
They're actually switching places. Very good, Levi. I'm glad you're noticing that and you spoke to it. And then let me put my D in here. The D is -4 down 2. So -4, -2. Okay. Now that I've got mine typed in, we compare the actual A to A and B to B and so on. And now we can see what Levi was noticing. And Savannah is correct as well. You're both correct. They are becoming negative and the X's and Y's are switching places. So this is the most interesting and I think complex of all the reflections we're going to look at because X's and Y's actually switch places. Let's type that in here. You can put it in your own words or use mine. X and Y both become negative or negated, and X and Y switch places. Look at A and A prime. 1, 4 turned into -4, -1. So they got negated and they swapped positions. X became Y, Y became X. And that's happening for all the points on reflection 3. It's not easy to see that just looking at the picture. I don't even see that. I look at the picture and I say, well, I can see the reflection, but I don't notice those numbers and what they're doing. Not until we write them down does that pattern start to kind of pop out. I want to move on to reflection 4, but I don't want to move too fast. Does anyone want to talk more or have any questions on reflection 3? Excuse me. Pardon me.
I don't have any questions.
Levi, thank you for telling me. Savannah, Anaya, Brooke, are you three doing okay so far?
Yeah.
Thanks, Savannah. And Anaya, thank you. Brooke, are you still there? Any questions so far? High five. Thanks, Brooke, for telling me. Okay. I should ask everyone else. Xavier or Victor, any questions from you two?
No.
No? Okay. Let's try our last reflection, guys, folks. So let's do reflection 4. Yes, the page looks exactly the same here. We're going to type in the A, B, C, and D, and then we'll look at the reflection points. So back on GeoGebra, we want to unclick on reflection 3 and hit number 4. And then I'm going to zoom mine in and center it so we can see those points better.
Okay, thanks, teacher.
Yes, thank you for telling me, for working
I'm
on.
learning to use this.
Yeah, I can see that it was a lot of trouble, and I don't want to. I don't want anyone to,
But it's okay. It's okay, teacher. I got it.
Yeah, for sure. So here's the new one. So notice that the original is the same. I'm not changing that up. A 1,4, B 1,3. So copy those in again for A, B, C, and D, everybody. And then we're going to look at the new points for this reflection. Okay, I'm going to start looking at the new reflected points. So the A reflection, the A prime here, it's over 4 up 1. Let's type that in for reflection 4 for A. 4 for X, up 1. Hang on, I'm going to put my ABCD in real quick. Okay, cool. Now for B prime. Over 3 up 1. And C prime. C prime is actually the same. If you notice this, C prime is like the same location as regular C, original C. Now, why is that? It's because it's on the line of reflection. So that's kind of interesting. So C prime is also over 3 up 3. Okay, and then for D, we're at 4, 2. Cool. Now, what is this line of reflection? Our last one was y equals negative x. Anyone want to take a stab or a guess at what this line of reflection might be? It is a y equals one. Y equals Savannah. Yes, y equals positive x. It's the like the reverse of the last line. If you look at the picture, it's going through the origin, and it goes up 1 over 1. Up 1 over 1. So it's basically a line with a slope of 1 that's going through the origin. So this line is another special one we have to be familiar with, as well as the y equals negative x and the 2 axes lines we did. Now, if we look at how to compare the points for the last part on reflection 4, can anyone tell me what's changing? What's staying the same? What's happening when you go from A to A prime, B to B prime? Reflection 4. Savannah noticed everything stayed positive. The y and changed places with the x's. Good. So no sign changes, no positive, negative changes.
Because of the way that it moves on the points, so how it goes like diagonally,
Yes.
right diagonally from the original points to the prime points, is what's keeping it positive and inside the same the positive and positive side.
Exactly. Yeah, like Levi's noticing that the original is all positive already, right? And then it flips over that red line diagonally. And it kept those points positive. What I want to emphasize to you guys, to all of you, is that the X and the Y are switching places. And what Levi's saying is correct. But maybe maybe I can change this thing just for a quick demonstration tomorrow. Okay, I don't want you guys to change yours. You don't have to. But let's say I changed my B. If you look at my screen with me, let's kind of change the shape of this thing quick. And if you want to mess with those, you can. It's all good. But if you just reopen the page, it'll come back to the original. So how I changed mine, I pulled back AB so that it's longer. And if you notice, B is already negative now, and so is A, right? It has -3, 3 for B, how I changed it. Now I do the reflection, and the new B is at 3, -3. So we're not getting sign changes, so to speak, but we are getting a switching of the X and Y still. Let's look at 4, or not 4, for A. A is over 3 up 4. And down below, it's 4, -3. So when we do this line, when we reflect over the Y equals X line, the X and the Y switching places. And there won't be any changes of the signs. But if one is starting negative, it kind of follows that number staying negative when it switches places. So these 4 things we noticed for reflection 1, 2, 3, and 4, we can think of these as like rules that we can use for all reflections. If we know we're reflecting over the y-axis, then we know that the x numbers turn negative and the y numbers stay the same. And if we reflect over the x-axis, then the x's do not change, but the y numbers all become negative. And if we have reflection over the negative diagonal, the y equals -x, then x and y are both negated or change sign, and x and y switch places. So we've only got 8 minutes left. I know that some people are probably at different points than others with typing these things in. Today's Tuesday, right? So if you have been having any trouble with using GeoGebra, with filling out these sheets, I'd like you to join me this afternoon at 3 o'clock because we can work a little more one-on-one, and I want to help you figure out how to use GeoGebra. I want to help you figure out how to answer these questions and work on it together. So we'll get a little more one-on-one time if you come join me at 3 o'clock today, and we can answer some of your questions if you don't want to ask in front of everybody. It's all good. I get it. But with only 7 minutes left, I want you all to go to slide number 7 with me. It looks like this. I've got it on my screen. And I want to turn what we noticed about these different reflections into like coordinate rules. Here's what I mean. If we look back up at our x-axis reflection, that was reflection number 2. X did not change, Y numbers become negative. So on my summary page, on page 7, slide 7, when we reflect over the x-axis, all your original x's are staying as their original x, but the y's are negated. So your original y's become negative y. So all original xy's turn into x negative y when we reflect over the x-axis. When we reflect over the y-axis, this is the next one, all original xy's This time the x's are changed, they're negated. The y's stay as their original y. So all xy's turn into negative x comma y. Then next up, we've got the positive, the positive line, y equals x. So what did we learn for y equals x line? This was reflection 4. The x's and the y's switched places, and there's no positive, negative changes that we could see. So we say all xy's become yx, meaning whatever you have given on your original point, they just get flipped. All x's became y's and all y's became the x's after doing the reflection. And then for the most complex one, the negative x line, And again, if you're not looking at my screen, you can. I'm typing in these rules. So forgive me if I wasn't very clear about that. Please come back to the Zoom call and check out what I've got. We're writing up some formal rules for the coordinates when we go over these different reflections. So this one was the most complex. This was number 3 we did. X's and Y's both become negative and they switch places. So how are we going to write that? All XY's become negative Y negative X. I'm negating both and we flip them or we swap them, swap positions. And you can see this happening by playing around with the GeoGebra activity I made. Here, I'm going to reload it so it looks like yours. There we go. You can click on the reflection and track those points. And that's why I set up this activity the way I did. So that way you would be purposefully writing down the original points and looking at their reflected points. And then we could see what's happening. And does that pattern happen for all the points in that reflection? You tell me. All we got to do is compare our originals and our reflected versions. The last thing I wanted you to do on this slide was put those rules one more time into your own words. So this is the very last page. It's slide 8. And what I'm asking you to do is write in your own words, describe what happens to the x and the y coordinates when we reflect over these following lines. So, for example, to reflect over the x-axis, you need to keep x the same. What we said earlier, x does not change, y numbers all become negative. So to reflect over the x-axis, you need to keep x values or x numbers the same. They don't change. But y numbers, y values become negative. So what do we do about the y-axis? What happens to those x's and y's? We're just restating on this exit ticket in your own words what happens to the x's and the y's when you do these reflections.
You just would keep the y values the same, but then the x values would become negative.
Very good. I didn't want to just give you these rules and tell you to memorize them. I thought it would be a little better if we got some practice. And I realize, practice is this using GeoGebra. Is that helpful? Maybe it is for some people, maybe not for some others. But it's what I found that I thought would be best to do some quick reflections and track these points. So I'm going to let you go for today. You're all released. I've got your attendance down already, but I want you to try answering those questions that you haven't done yet, if you haven't, on your own. Please come join me at 3 o'clock. I would love it if you all came, but you don't have to. If you want extra help, I would love to see you there. If you don't have these questions finished, come join me at 3:00 today, okay?
Okay, thank you, Josiah.
Levi, thank you. You have a good day.
Bye.
Bye, Savannah.
Thanks, teacher.
Bye, Victor.
Bye.
Bye, Anaya. Thank you.